Alright, and we will continue 1.4 measure of dispersions. And first one, make sure you know what is dispersion. Like, it is very hard to explain. But somebody put like use her hand yesterday, like okay, that is dispersion, right? And under the measure of dispersions, what do we have? So we have like range. Next one we have interquartile. Like we have Q1, Q2, Q3 and Q4, right? And make sure we know how to calculate for group data and ungrouped data, right? And today we will finish 1.4. Basically we will finish topic 1, okay? And we will finish with the variance and standard deviations. And this one, I guess you have heard the two terms before. Okay. So what is variance here? Right. You might agree, like the range is very easy to calculate. We just take the largest one minus the smallest one, then we can get the range. Okay. But if you take the largest minus the smallest one, so it won't give us like the clear picture of our data set. So we need like different measurement. Okay, and that's why we have like variance. Okay. So what is variance? We have definitions down there. The first points. The variance is a measure of how far the values. So basically we have here measure of how far the values, right? So if you want to know how far the values, so we should have like 2 points. Then we can know the difference between the 2 points. Okay. So what is the difference there? From data set and the mean. So that's why we calculate the mean, right? You calculate the mean and you take the original data set, you minus the mean. That is variance. The idea. Okay. And last one we have like the variance is computed slightly differently for populations and samples. So what do you notice here is when we calculate mean, median and mode, we don't take into account either that one is populations or sample. So basically what does it mean is if you are given a sample or a populations, the formula for measure of central tendency is the same. We don't have to consider sample or populations. Okay, the same goes for range and IQR yesterday. Okay, but when it comes to variance or standard deviations, don't get too excited to calculate your variance or standard deviations. We should identify first the data we have is like, oh, this one is sample or this one is population. So we need to identify first because the formula is slightly different. Okay, that is the point number 5. Okay. Alright, and this is the formula. So like I said, we have populations, we have variance. Okay. So identifying what is populations, what is variance. And I'm sure you know like what is the difference between populations and samples. Okay. So if you compare these two formula, and obviously that formula, this one is for populations, and this one is for samples by looking at the formula itself. Right? And again, you can Google the formula and you will have different formula. Okay. So first one, why you say the left one is the population? N. Capital N, correct. One more is, the first point is like we have capital N, correct. The other thing? why we say the left hand side is population? Obviously lah, because it under population, sir. Yes, correct too. Based on the notations or symbols there, what we can say? Yes, because we use here sigma. So if you use Greek letters, it means populations. If you use normal letters here, this one is S square, right? So this one is sample. Okay? Clear? The Greek letters there, or normal letters there. Okay? Second one, you can say, okay, because we have capital N there, it means populations. Or sample, you should have like n minus 1. Normally we use small n minus 1. So we can say, like, if the formula is like written correctly, the small n represent the sample. But I don't want to emphasize on the capital N or small n, but the most important one, you can see n minus 1 there. So if n minus 1, it means like sample. Okay? And we notice this, like this one and this one are almost the same. Like it depends on if you have, like basically we minus the mean. Okay? So the point here, like this one and this one, the term there, it comes from the definitions. Measure how far, correct? Okay, a data set and the mean. So basically we have to take either which one, either you can take data set minus mean or mean minus data set. It doesn't matter. Why it doesn't matter in this case? Because finally we should like square. So if you take, like, what does it mean here? If you take 4 minus 2, obviously 2, correct? And 2 power of 2 is 4, right? So just now we take 4 minus 2. So if we take 2 minus 4, what is the answer? Minus 2. But if you square minus 2, 4. So it doesn't matter which one you take. Okay, because they have squared. Okay, and because we take like the difference between data set and the means, that is the definitions of the variance. Okay, and again, this is like the most basic formula for the variance. If you Google later, you will see slightly different formula for the variance. They are okay because they modify the formula. Okay, and what is this one? Sum. So it depends on how many data sets you have. So if you have 10, then you should have like 10 data sets. Question. All right, and samples variance, this one. Okay. So if you look at the formula down here, oops. Why this one is sample? But you can see you have S there, correct? We have n minus 1 there. Sample. That's why we call this one sample variance. Okay? And now, if you compare with the previous formula, now you see like different formula. Correct? Are you here? Or you were like somewhere else? Okay. So first one, we have S square here equals to summations of x square minus summation of x square divided by n over n minus 1. That is the formula. Okay. What is this one? Summation of x square. Because we have another one. This one is like we do have summation of x, then we have bracket, then we have square. So from the written there, you can see obviously there is a difference there, right? Only the brackets there. So obviously it means something else. These two are not the same. So what is summations of x squared? The first one here. This one. You have to take your original data, square each of your original data. You square first, then we total up. Okay. Second one, this one. You sum your x first, then you get a value. That value you square. Okay. And then this one you divide by n, and the whole thing divide by n minus 1. Question. We will do examples later. Okay. Question? Good? Okay. This one is for ungrouped data. For group data here, so we have like S square here, obviously like sample variance. Now we have like F, and then we have X. So what if F then? Frequency. What is X squared then? Midpoint. So this one, how you're going to compute is, you have to take the frequency. No, first one you have to take the midpoint. So each midpoint you have to square. Right? And then the values there, you multiply by the frequency. And then you total up. That is fx, summations of fx squared. Okay? How about this one? Yes, you take your f, your frequency, you multiply by x first, total up, then that total up square. Okay? And divide by summations of f. What is summations of f? Total of frequency. Okay? And divide by summations of f minus 1. And this one, summations of f should be equals to n. Okay. All right. Okay. So a company that manufactures batteries is testing a new types of battery designed for laptop computers. They measure the lifetime in hours of 6 batteries, and the results are presented in the following tables. Find the variance of the lifetime. Alright. So try to use the formula. This one group or ungroup? Ungroup. Why ungroup? No class interval, correct? Populations or sample? Sample or population? What do you think? I should do like votings, then we can see the answer, right? Yeah, sample or population? So just normal guy here, Arman Izhar. Okay. Population or sample? Sample? Okay. Damia Irdina. Sample. Alright. And Rafiq Husaini. Why you say sample?
Sebab dia measure the lifetimes of 6 batteries. Company tu dia manufacture batteries, tapi dia test 3 battery.
3? Make sense? Do you get it? Like, if you, the most precise answer, no, not the most precise answer. The most precise question would be like, they will mention like, oh, this one is sample. You will see the word sample somewhere in the question. Then we cannot argue that one. Okay? So, but in real life here, why we say this one is samples? Because like, do they mention the sample? No, right? But a company, can you like imagine a company, a big company that produce 6 batteries only? Yep. So like that is almost impossible for a big company to produce 6 batteries. So that's why we can say sample. Okay? Alright, now do your work. Calculate. I can rest a bit. Apply the formula. What? But you need the data. I need to learn how to use this thing. Okay. Yeah, somebody asked the formula just now. Now somebody asked the question. Okay. Okay. All right. Come on, if not you will sleep like your friend. 1, 2. Ayo, calculator tak bawa. Phone tak bawa. Phone bawa. Phone bawa. Calculator tak bawa. Pernah tak kamu tertinggal phone? Okay, do calculation guys. I have like a whiteboard there. How about I call somebody to do at the front there? I do have. Do we have? Is it working right? This whiteboard? I hope. Oh, okay. Yes. Good. Okay. Random guy. We call this one first lah. Alif. Hakimi. Then go to the front. You can use the small whiteboard there. Yeah. What is the answer? Dua. Yo? Why you have a different answer? Do you have different question? Okay. Put S square at the front. Thank you. Where's the penutup? Okay guys, answer at the front is 2. Agree? Yes. Yes. Somebody got 31. Who else got different answer? What do you get? Careless. Mio? Mio. What you dapat? Okay. All 2? Yes? All 2? Me the front. Wait. The test won't wait you guys later after Raya. Siapa tak dapat lagi? Sat. Siapa yang tak dapat lagi? Bagi tahu dulu. Dah. You can ask your... Tak dapat. Betul. Okay, somebody ask why he got 106. Yes or no? Everybody got the answer? Yes. Who has not gotten the answer? Come on. Okay. 24. Do you have 24? Summation of x squared is 106. And answer is 2. Okay. Alright, so we have example 2 here. This is the marker, guys. You can pass to anybody you want for this example. Okay, the rest you can do, but who has the marker later, yes, erase that thing, you can do at the front. Why not? Yes, you have the freedom to pick anyone. Pilih-pilih yang mengantuk tu. Come on. Okay, somebody got the marker, guys. The rest, do this one. Come on. Try now, guys. Try now. what? Buat yang perlu saja. Starting from next week, we will do calculation, guys. Come on. Yes? Anybody got the answer? Or you're doing? Still okay? Yes, who has the answer? Macam lain. I guess you have the same question. And I believe we should end at the same answer. You have answer? Who has answer now? I want to know. Who has the answer now? Yeah? Blank? Pelik? Oh. Okay, what is the pelik one? Zero? Okay, who has zero? Come on. Nak puasa dah kot. Okay, first one guys, check. Like your friend here at the front, it has like summations of fx equals to 6825. Do you have the correct one? Not the correct one. Do you have the same one? This one. But it has 6825. Do you have 6825? Okay. So I believe this one is correct. Summation of f is 50. Correct?
Yeah.
Right? Summation of fx. Summation of fx squared. What is your answer? 101788020 sama? Okay, sama?
101
Summation of x squared. Summation of bisa fx squared. So now apply the formula. Come on, this is like standard one. Guys, you guys tak perlu nak shock lah jawapan you guys lain. Sebab memang tadi dalam exam pun jawapan lain. I don't know why. You see the quiz center kan, jawapan you guys lain. Somebody calculator's broken guys because of the very somebody has the answer guys, 5975.5. Oh, correct? Five nine 75.5 point. Yes. Hi guys. Can you write the final answer first here? Okay guys, this is the answer. If you have this one, good job. If you don't have this one, not so good. Okay. Come on.
Dia agak pening kat saya ada.
What is your summation here? Can I know this one? No. Total up this one. Tak dapat? Probably there's something wrong there. It's okay. Zero also. You have different answer. You will have different answer because this one is wrong. Not wrong. Okay. Okay guys. Thank you. Take this one. I have solution, I guess. So you can sit. Yeah. While sitting, you can look too. Okay guys. Let me explain. Check. Check guys. Check. Guys. Can I have your attention? Okay. So first one midpoint. Agree midpoint? Yes. Look here guys. Don't check your answers. And fx is this one. How do we get this one? You can multiply? 10. So we have 2 for 5 and do for all. Okay. And how do we get like 6002.50? This one, you square, multiply by f. This one you say fx square, so x square first. What is your x? This one. Alright? Square, multiply by 10. Do you get 6002.5?
Yes.
Yes?
Yes.
Okay. And summation of fx square, guys. Let me do the. You should have 1224412.5. And summation of fx is correct, 6825. And formula is up there. So s square equals to 1224412.5 minus 6825 power 2 divided by 50. Overall divided by 49, and answer should be 5975.51. Okay, don't talk yet. Compare your solution with this one. Make sure you know what went wrong with your solution. Okay? Done? Alright. Okay. Now standard deviations. Just now we computed variance. Alright. Now with the last topic, the last measurement, which is standard deviations. Alright. And just now, do you remember like how do we calculate variance? We have to take like x minus mean square, correct? Okay. So if we square there, it means like unit of our measurement is square. Okay. Because the variance is computed using square deviations. Okay. So the units of variance are the square of units of the data. What does it mean? Go back to your examples there. So this one, you get this one, right? 597.5.51. Do you know what is this one? Variance, correct? Okay. What does it mean here? Like, because we calculate the number of text messages, right? So this one, it says like we have like 5,975.51 message square. We don't say message, we say message square. Like if you can, why square? Because variance with square. So it means here like if we put messages after the answers there, we should put square. So what does it mean by message square? How do you explain message square? Very hard to explain. Like, let's say somebody asks you, how many messages you send, and then you say like 10 messages square. So people might think, okay, this guy is crazy. Like our human being, we should answer like 10 message, 5 message, then we know what it means. Okay, that is the weakness of variance. Okay, so we don't want variance, but it gives something, but we don't want. Okay. Alright, so for example here, in battery lifetime examples, the units of data are hours. Okay, and the units of variance are square hours, like jump square. What is the lifetime of that battery? We will say like 10 hours square. 2 jam kuasa 2. Yes. Okay, and it is very hard to explain. That's why we don't want variance. Okay. And in most situations, it is better to use spread that has the same unit of data. So what does it mean here? The same units of data. So if you're talking about battery here, so if hours, you want to compare with hours. We don't want to compare hours with hours square. And we don't want to compare like messages with the messages square. That's why we need the same of measurement. Okay, so if we need the same of measurement, we have to go back to standard deviation. Okay. We do this simply by taking the square roots of the variance. Okay, so this one is easy. Just take the square root. Okay, this quantity is called standard deviations. Okay, so if you take the square root of variance, you will get standard deviations. Okay, so the standard deviation of a sample is denoted by S, because S square is variance, sample variance. So if S is sample standard deviation. Okay, and this one is population, this one is sample. Okay, what do we have examples? Oh no, not yet. Okay, right. The standard deviations is measure of variations of all values from the mean. This one is like the same as the variance just now. We take the data minus the mean. Okay. The value of standard deviation is usually positive. It is never negative. Okay. Why? Because we square. From the variance we square. So if we square, then we don't have negative anymore. Okay. The value of the standard deviation can increase dramatically with the inclusions of one or more outliers. This one is fine. The unit of standard deviation are the same as the units of the original data values. Okay. So what does it mean here? The second point here, if you calculate your variance, then you won't have like negative variance. Okay. If you get negative variance, we may have zero variance, but not for that example. Okay, because zero is still positive. But we cannot have like negative variance. Okay, So if your answer for the variance is negative, then please redo. Okay? And if there is no negative for variance, it means like, okay, our standard deviation is no negative too. Because we cannot take the square root of a negative number. We will end up with a complex number. That is a different story. Okay. So the tricky one here, you can calculate the standard deviations, but if you have variance, if your variance is wrong, then your standard deviation is wrong. Like there is like connections there. That's why just now I want you like to calculate variance. And again, yes, you have different answer from the same question. Okay. And now, do we have exercise? Oh, answer that, guys. I just want to see the end of the slide. Oh, do you have this one? Oops. Alright, so this one is exercise 1 and 2. Go back and try this one. And this one is for group. Make sure you get the correct answer now. Later, not now. Okay. So next one is measure of shape. Do you have idea what is shape? Skewness. Symmetrical, right or left. That is shape. Okay. A distribution or data set is symmetric if it looks the same to the left as it does to the right of the center point. So symmetric is, I hope you imagine this way, that is symmetrical. Agree? Okay. What else do we have? A well-defined normal distribution is bell-shaped curve. So this one is symmetric, this one we call it bell-shaped curve. Do you know the bell? Like the shape is the bell. So bell-shaped curve is like asymmetry too. What else do we have here? However, there are data sets that are not symmetrical, having short or a long tail either on the left or their right hand side, which is we call it skew. And we have like skew to the right, skew to the left. Okay? Right, so skewness is measure of symmetry, or more precisely the lack of symmetry. So either symmetrical, left or right. Okay. What else do we have? Okay. Now we have the formula. Last time, I think yesterday we compare median and mean. Correct? Okay. So now we have formula. The skewness coefficient is also called the Pearson coefficient of skewness. And we have two formula here, which is SK, stand for skewness. Then we have to take mean divided by mode. So now we divide by S. What is S then? This one is also S. That one is capital S, skewness. Okay. So mean, you know how to find mean. And we know how to find mode. What is S then? Simple. Standard deviation. S square is sample variance. Small s here is sample standard deviation. That's why we calculate standard deviation just now. Okay. That is the first formula. We do have second formula, which is SK, skewness. This one we have to take 3 multiplied by mean minus median divided by S. And this S is sample standard deviation. Okay. So when we calculate this one, the formula is easy, but the tricky one is your standard deviations. If you get your standard deviation wrong, then your SK is wrong too. Okay? And what is the importance of SK or skewness here? When you get the value, you use this like indicator here. So if your SK is positive, greater than 1, it means right skew. So if your SK is negative, less than negative 1, it means left skew. So in between negative 1 and 1, alright, and this one we can say approximately symmetry. or 0 itself is like symmetrical lah. Okay, clear? Alright. Do we have examples? Alright, so there are examples here. The durations of stay in wards for samples of patients in hospitals around Jaya was recorded in days. From the record, the mean 28 days, the median is 25 days, and the mode is 23 days. Given the standard deviation is 4.2 days, what is the types of distribution? And what is the skewness coefficient? I think I click this one first, then conclude this one. Can you do now? Because we have mean, we have median, we have mode, and we have standard deviations. Calculate the skewness coefficient, and from skewness coefficient, say symmetrical left or right. Can you do now? Apply the Pearson's skewness, Pearson coefficients of skewness. I ignore this one. So SK, what is your SK? If you use the first formula, what is your SK? 1.19. 1.19. SK is from the second formula? 2.143. This one like first formula, this one is second formula. So type of distribution, symmetrical, skew to the right, skew to the left. Skew to the right. Why skew to the right? Because more than one or positive. Do you get 1.19 and 2.143? Yes? Yes, Sophia? Get? Question? Got your answer? Alright. Okay, I think this is the final slide. Yes. Take a look. Ask question. What do you understand from the summary here? Anything you want to clarify? Good. Alright, done topic 1.